Welcome to class today, everyone. I am Dr. Eubanks, and today we will be learning about the hypothalamo-pituitary portal system.
Sleep. Everybody's experienced it. College students are deprived of it. But what really goes on up here when you doze off? Once we have dozed off, our brains pass through 5 phases of sleep. Stage 1, 2, 3, 4, and REM, or rapid eye movement, in 90-minute cycles. Each stage is defined by its own unique brain waves detectable by an EEG and are produced by synchronized electrical pulses from communicating neurons that are best thought of as continuous spectrums of consciousness. In the first and lightest stage of sleep, stage 1, occasional muscle twitching occurs and activity slows down. It's during this stage that theta waves are present. In the second stage of sleep, stage 2, breathing pattern and heart rate slow, and there's a slight decrease in body temperature. It's during this stage that sleep spindles, or high-frequency, low-amplitude waves, and K-complexes, random bursts of high-amplitude waves, are prevalent. In the third and fourth stage of sleep, deep sleep begins, and the brain begins to generate slow delta waves. In the fifth stage of sleep, REM, or rapid eye movement, brainwaves speed up and dreaming occurs. Possible functions of REM sleep include brain development, learning, or possibly even memory. This stage is usually accompanied by muscle relaxation. It's also during this stage that alpha waves, similar to that of an alert and wakeful person, reappear. Well, I mean, that's interesting and all, but why do we even need sleep?
I think sleep is adaptive because when we were early humans, we could not see well in the dark and we were vulnerable to predators.
Yeah, but our ancestors had to wake up in the middle of the night to check on the kids in the fire. In the 1800s, people slept in 2 chunks, and they would even visit each other in between.
Okay, well then maybe sleep is recuperative. The day is really hard on our brains, and we need the night to rest and restore.
But if that were true, then larger animals would need more sleep.
Whatever.
Nerve signaling chemicals called neurotransmitters control our sleep and wakefulness by acting on different parts of the brain. The ventrolateral preoptic nucleus is often referred to as the sleep switch, although this is a gross simplification and several simultaneous and interactive processes are involved. A whole slew of neurotransmitters are involved in driving wakefulness and sleep, including dopamine, norepinephrine, orexin, acetylcholine, and serotonin. Serotonin, which is largely released by the ralphi nuclei, is converted into the hormone melatonin in the pineal gland of the brain. This conversion is under direction from the body's internal circadian rhythm and is sensitive to light.
The anterior hypothalamus in the basal forebrain area is thought to be responsible for sleep, while the posterior hypothalamus in the midbrain area is thought to be responsible for wakefulness. The pineal gland, a tiny endocrine gland no larger than the size of a pea, produces the hormone melatonin, which affects the modulation of sleep patterns. Melatonin is secreted in different amounts during the day or the night, and it is the mechanism that directs your internal clock or your circadian rhythms. Circadian rhythms are rhythms that occur during the course of a day. Recent research has hypothesized that the amount of artificial light at night is altering our modern circadian rhythms and could be the possible cause of rising rates of depression, anxiety, and ADHD because our bodies are becoming confused by these false signals. Anytime these neurotransmitters get disrupted from the presynaptic vesicle to the postsynaptic vesicle, this results in harmful sleep disorders.
Sleepwalking.
Insomnia.
Oh my gosh, the Sleep Disorders Family Reunion is so fun. I know, it's so good to see you guys. You want to see a picture of my cat? Yeah, what's its name?
Oh my god, narcolepsy, get up. I haven't slept in days.
Oh my god, sleepwalking.
Oh my
Sit
gosh,
down.